Question number 3, this is B3. And let's go ahead and look back at the directions. So you just go back to the letter. Model each scenario using a table, graph, and equation. So, table, graph, and equation. Hopefully you're paying attention because your next quiz I might just copy and paste this exact same problem. The school receives 2,000 email messages each day. There's a key word. I'm going to circle it. Hopefully in your graphic organizer, the table we did in the student edition, you'll recognize about each. Of those messages, 1,250 are junk mail messages. Model the email messages received by the school that are not junk mail. Not junk mail. Okay. So, not junk mail. That means that you just want real messages. So, of the real messages, how much are they? Yeah, I can just do 2,000 emails. That's total. Minus the junk is going to give us 750 real emails, right? Mr. Ringao is absent. Help me. And this student actually filled out the table correctly. 0, 750, 2, 1,500, and then 3. Okay, this is where something happened. So the student recognized that they're going from 750 to 1,500. And you should recognize that by the... was yours blank?
Yeah.
Okay, so this student was actually filling it out. Okay, and they're struggling with, is it going to be linear or is it going to be a exponential? Okay, so I circled this word because you're going to get how many emails per day? 2,000 each day. So although you're thinking 2,000 for each of these, remember we're just looking for the not junk mails or the real emails. So basically we're getting 750 real emails each day. So this each day here is you're doing what? Plus or multiplying? Plus 750 each day. So 750 plus 750 gives me 1,500. That's correct. Correct. Okay. 750 plus 1,500. 2,250. Raise your hand if you got that. Good. And if you add another 750, what do you get? 3,000. Okay. So what does this mean? So when I graph this, 750, so you should be really close to 800. If I look at this, I see that it is going up by 800 every 2 boxes. So 800 divided by 2 is 400. That means it's 400 per box. And 1 at 750 is pretty close to 800. And then 2 at 1,500. We'll use theirs. 3 at 2,250. So like maybe in the middle right there. And then 4 at 3,000. So that's at 2,800, so 3,000. Okay? So I got the table. I got a graph. And now I need an equation. Okay, this was the big mistake for your quizzes that I'm going to pass out tomorrow. Class, is this the same number? Yes. So what does that tell us? It's linear. Linear. Okay, if I know it's linear, what is the formula? Y equals mx plus b. Okay. Question. This first common difference, what is that called? The first common difference, which letter is it? M or B? M. Each day there are 750 real emails. That's my slope. Okay. The y-intercept B value is where it's starting. Put your finger somewhere on here where it might be. It's actually 2 locations. Okay? It's not a trick question, but it's kind of like up here where we don't have anything, and also over here. Okay, so let's try to get that in the graph. So if I connect the dots, and I think it would actually be appropriate to connect the dots because in real life, 1.1 day, right? So if I get an email at 4 o'clock in the morning, I can figure out how many emails I'm actually going to get. Does that make sense? It's not. It could be whole numbers, but emails come in all the time. You can make them decimals. And the other one is at 0. So class, if you're following this pattern, what number is that going to be? 0. So the y-intercept, pink, is going to be where crosses the, that's the same, right? It's an order pair, 0, 0. That means I'm going to put a 0 here. Do I write zeros, class? No. So make it super clean, you can have something like this. So that's a 0. Y equals 750x. This represents an equation that matches my graph, that matches my table for question B3.